Lord, I've come to you. Let my heart be changed, renew, flowing from the grave that I found in you. Lord, I've come to know the weaknesses I see in me will be stripped away by the power of your love. Oh, my God, let your love bring you, draw me to your side, and I'll rise to fight God, and I will share with you. Your spirit leads me on by the power of your love.
May I call Delia Grace of Class 11A for the words of welcome.
Warm good evening to one and all. Today it's my privilege to welcome you all to this session. First, I welcome our dear Father Principal, Reverend Father Varghese Eduthichira, who guides us through our journey and helps us to become better each day. Welcome, dear Father. Next, I welcome today's presenter, Ms. Amlin Mendes, who is a past student of our institution of the batch ISC 2018, who has now completed her bachelor's degree in renewable energy from St. Albans College, Ernakulam. I'm very happy to welcome you, Ms. Amlin Mendes. Next, I welcome the physics department teachers who took the effort in arranging this webinar. Welcome Sheena Miss and Sheja Miss. Next, I welcome all the teachers and students who joined this webinar and took this opportunity to iron their knowledge. Welcome, dear teachers and friends.
Thank you, Delia. Dear participants, we are extremely happy to invite our guest of the day, Ms. Amlin Mendes, for the keynote address. Let's listen to some secrets of immense potential of renewable energy.
Okay, so good evening to one and all, respected teachers and my dear Bosconians. First of all, I would like to thank our Father Principal, the Varghese Eduthichira, for organizing this webinar, which is a very relevant topic in today's scenario. And my special thanks to Sheena Miss and Sheja Miss for giving me this opportunity to interact with the students. And when I look back to my school days, a few years before, I was also a student like you, studying in Don Bosco School. And it was during my third standard, I came here, I took the admission here at Don Bosco. And from there till 12th standard, I don't know how to express it, our school memories. It was a wonderful and unforgettable moments that I experienced there. Whether it be in teaching level, like teachers who have helped me a lot. And I'm always thankful to them. And now, what I am today is because a major key role plays, school plays that key role. Actually, school has been part of my growth that is molding me to what I am today. It is after my 12th, I was not satisfied with my board examination marks. It was just like 70% marks that I scored in board examination. And I struggled a lot to study the syllabus, but I don't know what happened. But after getting admission for this course at St. Albert's College, and now after completing this graduation, I'm very much happy that I scored 90% above in this graduation level. And all credit goes to the school which molded me up. That is during the examination days, that is during board examination days, teachers and principal, father was there. They all were struggling to make us in the field of academics, to make good result in the field of academics. So because of them only I got up to this level, and I thank all of them. And my dear student, one sentence I would like to share to you, that you're truly blessed to study in this institution, because there are a lot of opportunities that are providing from this institution. So don't get pulled back from that. Grab your opportunities, and once you step out of this institution, you will know the value of it. That is, you will outshine in whatever field you are going. Even if it is a higher studies field, or even if it is in a job related field, I'm very much sure that you will outshine. So I wish you all the best for your future endeavors. And now let's, without further delay, let's move on to our webinar. Okay, so Sheena Miss, can I start the webinar?
Yes, please, Amlin, you can start.
My screen is visible, no, Miss?
Yeah, it's visible.
Okay, so let's start our webinar. In today's world, we are much aware about the energy. That is, everywhere we are hearing like save energy posters. We need to reduce pollution. We need to save energy for a better future. We need to maintain a sustainable development. So why all these things are repeatedly said? Because for our future, for a brighter future, we need to save energy, which is very important today in today's world. So for that, we have got two aspects. That is a clean energy source of energy, and an energy that is replenished. That is restored. Should not end with time. So for that, for these two factors, we are relying on renewable energy. That is what energy whose source never runs out. So that is what our webinar today about, this renewable energy whose source never runs out. Okay. So let's look now, before moving to this renewable energy, let us look what do you mean by this energy. So an overview of energy. So in physics, the definition of energy is clearly given as what? It is, energy is the capacity for doing work, or we'll say the ability to do work. You have all studied in your physics, no? And suppose for a small example, you can say, yeah, we need to push a table in front of you. What you will do? You will exert a force on that table, and what that causes the displacement of the table. So what you're doing, the work is done there, and that capacity for doing work is known as energy. And there are several forms of energy like potential energy, then kinetic energy, electrical energy, chemical energy, etc. These are some of the forms of energy. You might be familiar with this. And you can see one of the important aspects is all the forms of energy are associated with motion. Motion means it is movement. And another important aspect is energy can be converted from one form to the other. It's an important aspect. So in this regard, you can see the principle of energy conservation. You must have heard about the principle, you must have studied. Like energy can neither be created nor destroyed, but only converted from one form to another. That is what energy conversion is taking place. So if some of the examples of energy conservation, you can see in a battery, the chemical energy gets converted to electrical energy. Then what, in the bulb, the electrical energy gets converted to radiant or light energy. So that is one of the important aspects, and this is the overview of what is meant by this energy. Now the next one is classification of energy. So there are different types of energy classification. Like energy can be classified as primary energy and secondary energy, or it can be classified as commercial or non-commercial energy. And among the classification, one of the important classification is energy can be classified as renewable energy resources and non-renewable energy resources. Now, what do you mean by this renewable and non-renewable? It might be a new word to you, some of them. So let's look what is this renewable and non-renewable. Renewable sources means, from the word itself, you can understand that it is renewed. That is what, these sources are naturally regenerated, or they are not replenished, they are actually restored. They are not They are an unlimited source of energy, we call. Okay, and these renewable sources of energy are clean sources of energy. And some of the examples you can see are solar energy, then geothermal, wind energy, then hydro energy, tidal energy, biomass. These all are renewable energy sources. Then next comes for the non-renewable energy resources. It is actually the opposite of renewable energy. That is what these renewable and non-renewable energy resources, they cannot be replenished. They are not restored. That is, they appear only for a short period of time. And some of the examples are petroleum, then nuclear, natural gas, coal, etc. So these are the non-renewable energy resources. Now let's look deep into the sources of renewable energy. So the first source you can see is solar energy. Okay, solar energy. So in here you can see solar panels. I think most of you see the solar panels now, because almost in every houses we can see the solar panels now. So this is solar energy. Solar energy means, solar means it is sun. That is the light and heat that we get from the sun. Solar energy means what? Yeah, from the sun we get energy, and through the solar panels it gets converted to electricity. Okay, that is what meant by the solar energy. And the solar energy is a clean source of energy, and among these renewable energy resources, solar energy has got a wide variety of applications. And one important thing is it reduces pollution too, or no pollution at all. Then next comes the wind energy. Wind energy means, solar means what? The energy obtained from sun. So wind means the energy obtained from wind. That is, wind means what? It is like movement of air. We call it as simple words, movement of air. So from there, what? We get the energy. That is, here we can see wind turbines. These are known as wind turbines. Like they are aerodynamic plates. Called as aerodynamic plates. So these are installed. So when wind comes, what? Wind has got kinetic energy. So that gets converted to mechanical power. And here we have got a generator, and generator converts its mechanical power to electricity. So that is what meant by the wind energy. Then the next source comes, that is geothermal energy. Geothermal energy means, geothermal, it's actually meaning two words are there, that is geo and thermal. Geo means it is earth, and thermal means it is heat. So the energy that is obtained within the earth or from the inner surface of earth. That is from where? You know, the earth's surface is divided into three parts. That is what? Crust, mantle, and core. And core is the innermost part of earth's surface, and the temperature is very much high. So what we are doing is that, for that we have geothermal power plants. So these are geothermal power plants. So what they are doing there is, like wells will dig into 1 to 2 miles deep into the earth's surface, and there the heat is there. Okay, the high temperature heat is there. So to there we'll give this hot water, we supply the water there. So when water is placed there, what happens? It will generate heat, and that heat gets converted to electricity. So that's how geothermal energy becomes a renewable source. Then next comes the tidal energy. Tidal energy means, here you can see a device. This is known as the tidal power plants. Okay, so tidal energy means the energy that is obtained from tides. Tides means what? That is mainly caused in the sea. That is due to the gravitational effect of sun and moon on the earth. So when the effect occurs on earth, the sea shows some cyclic movements. So there what? Tides occur. So tides can be of two types, that is high tide and low tide. So during high tide, the water flows over these turbines. Look like leaf structure. So these plates are there. So water flows over these turbines. So when they flows over these turbines will rotate. When they rotate, they will generate electricity. Okay. And after, okay, that is in the case of high tide. Now, when it becomes low tide, the water flows backwards. So when it returns back, it will again rotates this turbine and will again produce electricity. Okay, that is what about tidal energy. Now the next renewable energy source is biomass energy. Biomass energy means, biomass means it is actually a renewable organic material, and it is mainly from the residues of plants and animals. Okay, so here you can see a cycle. So here you can see like a cycle. Look, trees and plants are there. From there we'll get the wood products. So these wood products are burned to form this biomass, and these biomass are taken to the biomass power plant. And from there, when we burn this biomass, steam gets generated and that gets converted to electricity. Now, in this biomass energy, there are chances of getting some byproducts. You can see the carbon dioxide. So, not only carbon dioxide, there are chances of producing methane, then carbon monoxide and hydrogen atom. So, carbon dioxide produced, they are consumed by these plants. The methane, hydrogen and carbon monoxide, they are oxidized with this oxygen and they can be used as cooking fuel. Okay. So that is what meant by this biomass energy. Then next comes the hydropower. The last one is hydropower. Hydropower must be familiar that this is dam. Okay, so hydropower means we call it as water power. So we use fast running water to produce the electricity. Okay. So these all are the sources of renewable energy. Now let's look what are the advantages of renewable energy over non-renewable, because we're telling that renewable energy sources should be used for a safe energy future. So let's look what are the advantages. First one is it's pollution free. Okay, it's pollution free. It does not cause any pollution. It's one of the major advantage. Then what? Second one is no cost, or you can say it is having a low cost. Then third one is easily available. That is, they are available within our surroundings. Whether it is solar energy or wind energy, anything, they're available, easily available. Then more, they recur in nature and they're inexhaustible. They're actually unlimited. Okay, they do not. They are getting restored day by day. That's what. Next point, it saves foreign exchange and generate local employment. That is for this renewable energy, we do not depend on these foreign countries. So that is, it is available within our own country. So we can use that renewable energy resources, and that generates for local employment. Then the next point is transmission losses are almost nil. That is, after consuming this energy, some losses may occur, and that losses are almost nil. Then they do not leave any byproducts. Byproducts are not at all there. But in case of biomass, there are byproducts, but that is used as for cooking fuel. So we can say that there are no byproducts, and it will not produce any harmful gases. It's eco-friendly. So these are the points, that is advantages of renewable energy over non-renewable. Now let's look to solar energy and wind energy into detail. So let's first take solar energy. Solar energy means, as I said, it is what solar means. It is the radiant light and heat from the sun, and that what we are just converting that into electricity using some of the technologies. Okay, there are many types of technologies in solar, like solar heating, photovoltaic, solar thermal, etc. And the different types of solar energy. These are the different technologies of solar energy. There are four main types, that is photovoltaic systems, then solar water heating systems, solar power plants, and passive solar heating. So among them, photovoltaic and solar water heating systems, we will come into detail. Let's look what is solar power plants and passive solar heating. Solar power plants means they're actually mainly installed in industrial levels, etc. So there what the high temperature heat is generated, and that gets converted to electricity. That is what meant by solar power plants. Now, in the case of passive solar heating, here they are mainly implemented in windows. Okay, we call it as a passive solar design. So they mainly implemented in windows. So there, when sunlight comes, what the heat gets stored there, mainly in concrete slabs, etc. So heat gets stored there, and that stored heat can be used for daylighting or cooling, heating, etc. So that is what passive solar heating. And in this passive solar heating, as I said, it is implemented in windows, and these windows, they are actually faced to the south side. Because in our country is in the northern hemisphere side. So sun is always on the south side. So in order to get the maximum amount of energy, we are facing it more in the south side. Now let's look to the main topic, that is photovoltaic systems. So photovoltaics in short we call it as PV, photovoltaics. And these are two words, photovoltaic. Photo means it is light and voltaics means voltage. So with the use of light, we are generating of voltage. So photovoltaic means it is the conversion of light into electricity using semiconducting material. That is the panel we are using, it is made up of semiconducting material. So that is one of the photovoltaics, and that effect is known as, exhibiting the effect is known as photovoltaic effect. And that effect is what commercially utilized for the electricity generation and in the photo cells. And the types of PV systems, we have mainly two types of PV systems, that is grid connected PV systems and off-grid PV systems. So these are the two types of PV systems. And there are three main types of PV technologies, that is monocrystalline panels, polycrystalline panels, and thin film panels. So these are the three main types of PV technologies. Okay, we'll come to the detail later. Now before that, let's look what you mean by a solar cell. A solar cell means otherwise known as the photovoltaic cell. So it is a device that converts energy from the sun directly into electricity using what effect? This photovoltaic effect. Okay, and here you can see this one is known as the solar cell. And that solar cell, what they are interconnected, they are connected together to form a module. So in a module, there are around 36 solar cells. And this module is known as the building block of PV system. And one or two modules, they connected together to form a panel. These are the, we call it as solar panel. And the panels, if they connected together, we call it as an array. And these is not, they are known as the power generating unit. So a cell connected together to form a module. There are 36 cells in a module. And one of the modules, they together form a panel. Panel gets what when they connected, and one of the panels are connected together, they form an array. And now this one is based on the types of solar cells. That is, there are different types of solar cell. There are three main types. So the first generation is known as the wafer-based silicon. That is, the semiconductor material they use this silicon-based solar cell we call. And there are two types of silicon-based solar cell: monocrystalline solar cells and polycrystalline solar cells. These are the two main types of silicon solar cell. Now, the second generation is thin film solar cells. Thin film means they will be using one or two semiconducting materials, and that is fitted with a glass. So there are different types of thin film solar cells too, like amorphous silicon thin film solar cells, CDT thin film solar cells. CDT means this cadmium and telluride. So cadmium telluride thin film solar cells. Then other one is we have gallium arsenide solar cells. Okay, so these are the second generation thin film solar cells. Then we have the third generation, that is the emerging technology. So the new emerging technology, we have got nanocrystal based solar cells, then polymer based solar cells, perovskite based solar cells, then dye-sensitized solar cells, and concentrating solar cells. So this is an overview of different types of solar cells. Now let's look the materials. Okay, that is, what are the different layers in the module of a solar. So here we have, this is a module, that is 36 cells are there, and this is a module. So here we have the first one is the junction box. Okay, junction box, this is the bottom part. So junction box means we have got many wires to connect it, so that wires meet up here in this junction box. Okay, that is for the connection. Then we have the back sheet. Here, back sheet is mainly for the protection of inner components. Okay, inner components, that is mainly for the protection. And that is the outermost layer. Then we have an encapsulant. Encapsulant here use this EVA, that is ethylene vinyl acetate. This is the encapsulant we have used here. Then we have the solar cells. Again, we have an encapsulant there. Then we have the tempered glass. Tempered glass means it is mainly for the protection. That is, if you're using an ordinary glass, it won't be that much safer to use it, because something is falling on the solar panel that we supposed to break it. So For that, we are using this tempered glass, and it's actually 6 times stronger than the normal glass. Then we have this aluminum frame. The aluminum frame is first part, and that is mainly for the resistance to corrosion. It is lightweight. So these are the layers of solar module. Then the solar cell types. So this, which are the main solar cell types that we are using now? Okay, so there are 3 main solar cell types we are using. That is monocrystalline solar cell, then polycrystalline solar cell, then thin film solar cell. So monocrystalline means it is the most efficient solar cell. So monocrystalline means I told mono and poly, they are silicon type solar cells. So monocrystalline means what? A single crystal is used here. Since a single crystal is used here, it is the most efficient type of solar cell. Okay, and since it is the most efficient type, they are more expensive, and they are less sustainable. Okay, so the efficiency of this monocrystalline is about 16 to 18%. Then coming back to the polycrystalline solar cell. Polycrystalline means what we are using. Poly means many fragments of silicon it is used there. So since many fragments of silicon is used there, the electron mobility will be very low. So since that mobility is very low, it is less efficient. Okay, it's less efficient, and it is less expensive. Since it is less efficient, it is less expensive, but it is more sustainable. So that is polycrystalline solar cells. Then this is thin film solar cell. Thin film means what? We're using 2 materials in that. So this one is the least efficient one. Okay, least efficient one, and since it is least efficient, it is least expensive too, but it is the most sustainable one. So for commercial applications, we mainly rely on these monocrystalline or polycrystalline. Okay. Now let's look the types of PV systems. So mainly we have 2 types of PV systems, that is on-grid solar system and off-grid solar system. So on-grid solar system means this system is directly connected to the grid, that is to the utility power. Okay, so here how it is working is that we have got your solar panels are there. So when sunlight falls on the solar panels, what current gets generated, and that is the DC current. Current from the solar panel is DC. Then we have the inverter. So inverter converts DC to AC. It is alternating current, and that AC is supplied to the houses for our purpose. Now, if there are any remaining currents after our usage, if there are remaining current, that gets supplied to the utility power or to the grid. That is what meant by on-grid solar system. Okay, so from solar panels, AC is produced to the inverter, DC gets converted to AC, and AC is supplied to the home, and after the usage, with the remaining power, that gets to the grid, and that is why it is known as on-grid solar system. And the second one is off-grid solar system. Off-grid means it is not connected to the grid. Here we have a storage system, that is battery. Okay, from battery we have. So here from the solar array what the current is there, and here we have a charge controller. Charge controller means it improves the efficiency of this battery bank. That is, it mainly protects from overcharging. Okay, so that is for the function of charge controller. So from there what is the same, that is DC it gets converted to AC through this inverter, and AC gets to the loads, that is enough for home usage. So these are the 2 main types of solar PV systems, on-grid solar system and off-grid solar system. Now let's look the second type of PV system, that is solar system, that is solar water heater. Solar water heaters means they're known as the solar domestic hot water systems. That is, it is an effective way to generate hot water for your home rather than the traditional water heaters. Okay, and it mainly works on a principle known as thermosiphon principle. Okay, this I'll explain to you when it comes to the working of solar water heaters. So just with the name, thermosiphon is the principle of solar water heater. And we have 2 main types of solar water heaters, that is evacuated tube collectors and flat plate collectors. So these are the 2 types of solar water heaters. Now let's look to the evacuated tube collectors. Evacuated tube collectors means, it is shortly you can say ETC, evacuated tube collectors. So this one is actually tubes are there. Okay, tubes are there, and these are borosilicate tubes. And these solar water heaters are mainly used for residential and commercial use. And here, this one is actually easy to install. Maintenance is very much easy, and low cost is there. And life is around 15 minutes. Okay, so that is what about the evacuated tube collectors. Then next comes the flat plane collectors. Flat plane collectors means it is from the word itself, we can say flat plates are there. There is a metallic sheet, and in the metallic sheet above it, we are placing a glass cover too. So that's why the name flat plane collectors. So here also same function only, but this one is also easy to install. Life is around 25 years, but main thing is that the maintenance is quite difficult. Since it is a glass thing, suppose a breakage is happening, the maintenance is quite difficult. So many of them are relying mainly on this evacuated tube collectors. Now let's look to the parts of solar water heater. Okay, so these are the parts of evacuated tube collectors since it is using commonly. Now the first one is frame and stand. Frame and stand means it is mainly to hold the collector tubes, and to hold this tank only we are using this frame and stand so that it will protect the components. Okay, so that is why we are using this frame and stand. Second part is tank. That is the main part of solar water heater system. Okay, tank, and we have got two tanks. This one is known as the outer tank, and inside it we have the inner tank. Then the next part is puff insulated tanks. Puff insulated means between this inner and outer tank, we are giving an insulation that is puff. Puff means polyurethane foam. Okay, that is mainly for the thermal insulation to mainly to retain that heat of the water. Okay, for long duration, we are using this insulation. Then comes next part, that is surge tank. Surge tank is an auxiliary tank. It is actually connected next to this main tank, and this contains a cutoff valve. That is water from the main tank, it directly comes to this surge tank. Okay, so that's what we are using here, surge tank, and it is mainly to reduce the water pressure. If water pressure is rising, it will reduce that pressure to make it a constant pressure. Then we have the collectors. Collectors, I told you that it is made up of borosilicate glass. Two glasses are there, so that is how collectors are formed. Then next final part is wash. Wash means to collect to fix these collectors onto this tank. Wash is there so that it won't push out of the tank. Okay, so these are the main parts of a solar water heater: frame and stand, then tank, inner and outer tank, then puff insulated tanks, polyurethane foam is used, then surge tank and auxiliary tank, then collectors made of borosilicate glass, then the wash fix. Now let's look to the working of solar water heater. So working means we have got a main tank in our home. Okay, it's actually installed at the top. So that main tank is there, and here we have this surge tank. Surge tank is the auxiliary tank, and the main tank is kept 0.3 meters above this surge tank. Okay, so water from that main tank, it will enter to this surge tank. Okay, after entering to the surge tank through this inlet, it will go to this water tank. Okay, that is a main water tank. Now, after going to this water tank, it gets stored here. That is in the inner tank. And after getting the water, after getting to this inner tank, the surge tank will cut off. It won't allow further water to enter from the main tank. So after flowing the water to this inner tank, that will be giving to this tubes. That is, water will be given to these all tubes. Now, when sunlight falls on these tubes, what happens? Water gets heated. So here we are using that thermosiphon principle. That is, since cold water has a very high density than hot water, the cold water gets at the bottom and the hot water rises. Okay, and that is happening, and from there it will go out through this outlet. Okay, and here we have a drain is the drain that is for removing the impurities. We are placing a drain here, Then some of the valves that we use, the union valve is there. Then we have an outlet, that is for the water to go out. Then we have the NRV valve, that is the non-return valve. It won't allow the water to flow back. So that is what is the non-return valve. So this is the working of a solar water heater. Now let's come to the second renewable energy resource, that is wind energy. Okay, it's wind energy. And wind power, it is one of the fastest growing renewable energy technologies after solar energy. Okay, and what wind is used to produce electricity, as I told, when the wind hits this aerodynamic plates or this turbine, what that kinetic energy gets converted to mechanical power, and here we have a generator, and generator converts the mechanical power to electricity. And let's look about types of wind turbines. We have two main types of wind turbines, that is HAWT and VAWT. HAWT means it is horizontal axis wind turbine. VAWT means it is vertical axis wind turbine. So this one is known as HAWT and this one is known as VAWT. Okay. So in HAWT, you can see these type of wind turbines must be familiar to you. And in our country, mainly in our Palakkad side or Tamil Nadu side, you can see this types of wind turbines. Okay, so they have got these plates. We call it as aerodynamic plates. Okay, these plates are known as aerodynamic plates. And here we have the rotor. It is connected to the rotor, and here we have the generator and all. So this HAWT is that wind turbine, and VAWT. When it comes to the VAWT, this is the structure of VAWT. So it is actually almost it is transverse to the wind direction. Okay, and here the generator and all the components are situated in the upside, but in VAWT all the components are situated in the ground level itself. So that maintenance is a little more easier when compared to HAWT. Then this is the basic parts of a wind electric system. Look, this is the rotor. This is HAW. Okay, so this is the rotor. Then what we have the generator there or an alternator. Then tower to hold it. Then we call it as tail. This one is known as the tail. So this is so these are the basic parts of a wind electric system. And how it is working, I told you what when wind blows, the kinetic energy transforms to mechanical energy. And what the gearbox is there that is connected, though that will spin and spins a generator, and that produces what the electricity. That's what a wind energy work. Now we have completed our two renewable energy, that is solar and wind energy. And the next topic, it might be new to you, that is solar tree. Okay, so solar tree means it is actually an emerging technology in the field of solar energy. And the solar tree means it's actually a tree-like structure which contains solar panels as leaves. So you can see a tree-like structure, and in place of leaves, small solar panels are connected here. So this we call it as a solar tree. And it is mainly invented for the purpose what? Since it requires less space, okay, mainly for the public usage. So these can be installed in public places and in public parks, public places, and even in houses that you can install it outside your home. And these trees require what? Less space and can be easily installed too. Okay, and mainly used for the applications like street lighting, then home supplies, and in industries. Okay. Now, when used in a large scale, it can be used as what? Like a charger. We are implementing it in a public space, what you can use it as a charger or a Wi-Fi spot or a shed to park vehicles or a surveillance camera and so on. So this is a solar tree, and these are the other designs of a solar tree. And this design is actually based on a method called spiraling PHOTOVOLTAIC method. It is actually a method that is developed by some person. So it is actually known as the spiraling PHOTOVOLTAIC method, that is trees are oriented in such a way. Okay, so these are known as solar tree. So this one is a circuit diagram, that is for our final year project in our degree. We made a prototype of the solar tree using two solar panels. So that circuit diagram is this. Okay, so you can see P1 and P2, they are known as the solar panels. Then C1 and C2, they are known as the capacitors. Then we have got D1 and D2, they are known as the diodes. Then LM780, which is IC 8-volt regulator. Then D is known as the lead acid rechargeable battery. Then we have the switch for on-off purpose, and then the load. Okay, so this is our circuit diagram which we made. The component function of the components will come across later. That is in a higher class setting. So this was our project. That is, we made the circuit in the breadboard. This one, the white part is known as the breadboard. It is a device that is mainly used in electronics and all to connect it. That is to make the circuit. So we have connected this. Then wiring is done with 2 solar panels we have used. So wiring is done. And these whole circuit is placed inside a box. And finally, this one, it's our prototype, that is our degree project. This one is the solar tree model. We are using 2 panels here. These are mini solar panels. Okay, mini solar panels. So we have made this prototype of a solar tree. And this one is in India. It is not much popular. The solar tree is not much popular in India, but in West Bengal, scientists at CMERI, that is Central Mechanical Engineering Research Institute, they have installed the solar tree in West Bengal. It is the largest solar tree in India. So you can see that solar panels are there, like tree-shaped model. So that mainly for the purpose of agricultural activities, that is to run pumps, tractors, etc. The scientists have installed this solar panel. So you can see this. This one is the largest solar tree in our country. It's at West Bengal. Okay. Now, so last topic, that is some tips to save energy at home. Since we are dealing with energy, you need to know somehow to save energy. Okay. So these are some of the 12 simple tips to save energy at home. The first one is turn off lights when leaving a room. Okay, so whenever you leave a room, just turn off all lights, with all fans and all. Okay, so they can save energy. Then switch to energy efficient appliances. Then use LED lights. That is, what these are energy efficient appliances or devices. So if you're using energy efficient mode, you can save energy in a better way. Unplug devices when not in use. So after charging your phone, you have to unplug it. So unplug devices when not in use. Then keep thermostat at low temperature. Thermostat means it is a temperature sensing device. So that should always be maintained at a low temperature to reduce this energy consumption, reduce the heating bill. Then reduce water consumption. Water consumption, that is what you have to reduce. That is, don't use unnecessary water. Then what you have to reduce the water consumption to save energy. Then use smart automated devices. That is, nowadays you can see the device on we can just control it in one click in your smartphone itself. So use smart automated devices. Then switch to double glazing. Double glazing, it reduces the energy, the heating bills. Then cook with the lid on. If you're cooking with the lid on, the food cooks much faster, so that you can save energy. Okay. Then use a smart meter to track the usage. So if you're using a smart meter, power consumption can be reduced and you can clearly view the power consumption. Then wash at a cold temperature. Okay, so when you're washing, you have to wash at cold temperature. If you're using the hot temperature, or again energy is lost. So wash at a cold temperature. Then won't use solar power devices. That is the main way to reduce the energy or save energy at home. So these are just some of the simple tips to save energy at home. So what you need to do, you have to conserve energy for a brighter future. Okay, don't just stay in your words. You have to be practically involved in it. Okay, so that's what I have done. This 12 tips to save energy at home. So conserve energy for a brighter future. That is what save energy and build your future. Okay, now came to the end of this session. So if you have any queries, you can ask to me.
Thank you, Ms. Amlin, for making us to understand the renewable energy, a clear winner for a future to lead. It's a question time. Now, dear friends, if you have any doubts, you can raise your questions.
Ma'am, I have a question. I am Alan Stephen of class 9A. My question is, some devices like laptops, batteries, cell phones, etc. use DC. Solar systems convert DC to AC by inverters. So how DC powered devices get their power?
So thank you, Alan. Look, from solar panels, we get the DC power, and that gets converted to what AC through this inverters. But in our homes, majority of the appliances are what AC powered, okay? But there are some devices like our cell phones, as Alan said, cell phones, batteries, mobile phones, etc. They are DC powered devices. So how they get power means in that charger itself, they've got a power adapter. Okay, so there is a power adapter, and when AC comes, that gets converted. Power adapter converts this AC to DC direct current, so that mobile phones, chargers, etc., it can be powered with this DC.
Thank you, ma'am.
Good evening, ma'am. My name is Andrea from grade 9. My question is that which wind turbine is more efficient and better, hot or what? Why?
Okay, Sandhya, thank you for your question. I told wind turbines are of two types, HAWT and VAWT. That is horizontal axis and vertical axis wind turbine. So, which is more efficient? It is quite difficult to say because HAWT we are mainly installed in areas where the wind stream is quite steady. That is, wind is continuously getting in that area. So, if that wind is continuously getting in that area, we can use this HAWT, that is horizontal axis wind turbine. In the case of VAWT, those wind turbines are mainly installed in places where low wind speed is available. Okay, in that areas only VAWT is installed. So we can't say which is more efficient or more better because HAWT is mainly used nowadays, and that is mainly used for steady wind stream. Okay. And if we're taking about their differences, you can say for VAWT and HAWT. In the case of HAWT, their all components are placed at the top of the turbine. But in the case of VAWT, their all components are placed at the bottom, so that maintenance will be easy for VAWT than HAWT. Okay.
Thank you, ma'am.
Dear students, you will get a link in chat box. So you are requested to submit it after entering all the required details correctly. Okay, so your attendance link will be sent through the chat box. So you are requested to submit it after entering all the required details correctly. This is for the students of class 8, 9, and 11. Okay, thank you.
Good evening, ma'am. I am Prashasti Gupta of class 9th A. Can you please explain the details of BVOC, Renewable Energy course?
Okay. I'll explain it. The slide is visible now.
Yes, Amlin.
Okay, so PHOTOVOLTAIC Renewable Energy means it is a course that is Bachelor of Vocation in Renewable Energy Management. And this you can take after your completion of your 12th standard. Okay, after completing your 12th, you can opt for this PHOTOVOLTAIC Renewable Energy course. And it is a 3-year course, and eligibility year is completed 12th standard with PCM or PCB, like science stream subjects from a recognized board. So BVOC means it is Bachelor of Vocation, I told. It is mainly this course has introduced a few years before. It is mainly to promote the vocation training in India. Okay, so after graduating from this renewable energy course, you can directly opt for a job in this renewable energy field. So that is the main aim of this course. And some of the features of this course are you have got 2 internships during your curriculum. Okay, that is during your first year and second year. That is the first internship is HOT, that is hands-on training program for a period of 28 days. And the second internship is OJT, on-job training program for a period of 28 days. So these two are the internships that is provided in this course. So here what you're doing is that you'll select the company that is based on renewable energy, whether it is a solar or any company related to renewable energy. And there you will go there and you'll be given a training on your topic. So you need to select a topic on each internship. That is for me, my group has done training on that is HOT, first internship training on solar panel installation. So we went to a company and there they made us to study about the solar panels, their installation. Then we went to many sites to view the solar panels installation, etc. That's what. Okay. Then for the second internship, my group we went to a company at Coimbatore. That is our topic was about solar water heaters. So you can select the topic that you like. That is, there are many topics like solar water heaters, then solar designing, manufacturing. Then in the case of wind also, there are many other topics. So you can select your topic of your own choice. So you need to go to that company and training will be given. And since it is part of this curriculum, after completing your internship, you'll be having an examination on it. That is, you need to present a report on your training. Then you have to present a PPT before the examiner. You have to explain the PPT. Then they ask for the Viva and you have to answer their questions. That's all about internships. Then in the final year, you'll be having a project. That's what I showed you, that solar tree model. So in that final year project, you need to make any prototype or any model related to renewable energy field. Then for the course structure, this is one of the important features of PHOTOVOLTAIC degree programs. Any PHOTOVOLTAIC, okay, if you're choosing any PHOTOVOLTAIC degree, this one will be given to you. That is, after completion of first year, you will be getting a diploma certificate. Then after completing your second year, you'll be getting an advanced diploma certificate. Then after completing your third year, you'll be getting a degree certificate. Diploma certificate means they will be having an exam on diploma certificate, like diploma exam, and that is from the National Council for Green Jobs. Okay, they are actually that is actually doing this diploma exams and all. So after attending that exam, if you're qualified for that exam, you will get the diploma certificate. Okay, and after diploma certificate, you can opt for this advanced diploma certificate. So the main reason is, suppose after your first year, you're dropping from this course, but you still have this diploma certificate. So if you're going through a company and all, that will be having a value. Okay, since you have got this diploma certificate, that's the main thing. Okay. Then the main subjects under study, these are the main subjects under study in this renewable energy, physics, electronics, chemistry, solar energy systems, then wind energy systems, renewable energy sources, green technology, entrepreneurship. Then we have got project management, environmental education. So these are the main subjects under study, this renewable energy. And what all careers you can choose after completing this course, PHOTOVOLTAIC Renewable Energy. That is, you can mainly opt for a company, a solar company or a wind company. So then the post you are getting will be project manager, one who handles all the projects, or an analyst, one who collects the data and all. Or in the case of installation and technician, that is, you have to go to so many sites and you have to install it. You have to technically make it available to your customers. That is the what installation and technician. Then the environmental consultant is there. Then you can opt for teaching field. That is, after completing this PHOTOVOLTAIC Renewable Energy, you can, if you wish to continue the teaching field, you can opt for the higher studies. That is PHOTOVOLTAIC Renewable Energy. Okay, that is the PHOTOVOLTAIC Renewable Energy or MSc Renewable Energy. So you can take that as a PG studies, and after that you can write an examination regarding teaching field, and you can go to the teaching field too. Then if you're keenly interested in doing a business, working like on entrepreneurs who are keenly interested in that, you can go to the business field. So these are the careers that we get after completing this renewable energy. So I hope it's clear.
Yes, ma'am. Thank you.
Thank you, Miss Hamlin and dear friends. Now I call Catherine Rose of Class 8A to propose the vote of thanks.
Good evening, one and all. First of all, I'd like to thank our respected father, Verghese Edithira, for giving us this opportunity to know more about renewable energy. In the same respect, I'd like to thank our resource person, Ms. Amlin Mentis of Science Department from St. Albert's College, for spending your precious time with us in this evening and enriching more on the topic renewable energy. I would also like to thank our teachers for conducting this webinar and letting us know more about science and keeping our mind doubt-free. At last but not the least, I'd like to thank all my dear friends for your wholehearted support and preparation. Once again, thank you all for joining this webinar section. Have a great day.
So, dear Amlin Mendes, thank you so much for your brief explanation about renewable energy, and it was well presented and explained. And definitely, our children will carry out to save and preserve energy for the future. Thank you, Amlin,
Yes, thank
for
you.
accepting this webinar. And I wish you all the best for your higher studies.
Thank you.
And I thank our dear students, Sneha Roy, Shive Sharma, Prashasti Gupta, Alan Stephen, Sandria Mary, Delia, Catherine Rose, for the smooth conduct of this webinar. Thank you, children. And on behalf of Science Department, I thank Shiju sir and Nayan sir for the technical support. Thank you, sir, for spending time for us. And also I thank Shija Miss for guiding and helping me to organize this webinar. Thank you, Shija Miss. Shive, you can continue.
My dear friends, replacing traditional sources of energy completely with renewable energy is going to be a challenging task. Let's together face this challenge. With this, our webinar comes to an end. Thank you, Father, teachers, and my dear friends for your wholehearted participation.
Miss, can I lead the meeting?
Yes, yes, you can.
Okay, thank you.